Our fourth objective for this section is to add and subtract fractions. And we're going to talk about the easier kinds of fractions to work with first. We're going to add and subtract fractions that have common denominators. So if I go back to the pizzas that we were looking at earlier, if I've got a pizza that's cut into 4 slices, and I have another pizza that's cut into 6 slices. See if I can make 6 equal slices here. Pretend those are all the same size. Eating 2 slices of this pizza is a lot more pizza than eating 2 slices of this pizza. So in order to be able to add or subtract fractions, we need to make sure that all of the pieces of pizza that we're talking about are the same size. So those are the problems that we're going to look at first. So if we're talking about fractions that already have matching denominators, you add the top, or the numerators, or subtract, I guess, if it's subtraction. Add or subtract the top, keep the bottom the same. Okay. So going back to my pizza example again, if I have 2/4 of a pizza, and over here I have another 4/4 of a pizza, altogether I have 6/4 of a pizza, which could be reduced into 3 halves, or 1 whole pizza and another half of a pizza. So some examples for this: 7/15 plus 2/15 gives me a total of 9/15, but I can take a 3 out of the top and bottom here. There's my 1. So this is the same as 3/5. Here I've got a subtraction problem. 14/27 minus 5/27 will give me 9/27. And we've reduced that fraction already on the previous objective. 9/27 reduces down to 1/3. Now let's look at some problems that don't have matching denominators. So I said earlier that if they don't match, the first thing that we need to do is get these pizzas. I'm going to try to make a 6th pizza that's more, that the slices are more the same size. We don't want anybody getting cheated out of their pizza slice here. Okay, those look a little more even. So if I've got pizzas, one is cut into pieces that are 4 each, and the other one's cut into pieces that are 6 each, I need to make these pieces similar sizes before I can start comparing how much pizza I have from one pizza or the other. So by taking each of these 1/6 of a pizza and cutting them in half, and then taking each of these 1/4 of a pizza and cutting them in 1/3, I end up creating pizzas where the pieces are the same size. So let's look at how we're going to do that mathematically. We want to first convert to like is not spelled with an F, like fractions. So remember, like fractions again are the ones where the same amount of stuff is represented. It's just cut into different size pieces. Okay? So we want to create fractions that are like with the same denominator. Having trouble spelling tonight. So looking at these pizzas, when we started, this pizza was 4/4, and it became 12/12 by cutting each of those extra slices. Oh, I lied. That one's the 6/6. It started with 6 pieces, and we cut each of those pieces in half in order to make it into 12/12. This pizza started as 4/4 of a pizza, and we cut each of those slices into thirds, right there, 3 more slices over there, in order to also get 12/12. And with those matching denominators, now we could compare a portion of this pizza to this one, where we couldn't previously. So you convert to like fractions with the same denominator. Then once the denominators match, then it's the same as the page before. You add or subtract the numerators. So looking at 9 and 12, the smallest number I can think of that both 9 and 12 will fit into, not that fit into them, but that they would fit into, both fit into 36. In order to get 9 to be 36, I need to multiply it by 4. So I'm going to do the same thing on the top, and that new fraction is going to become a 16/36. And in order to get 12 to become 36, I have to multiply it by 3. So I'm going to do the same thing on the top there as well to make 15/36. 5/12 and 15/36 are equivalent or like fractions, and 4/9 and 16/36 are equivalent fractions. So these are equal, and because they're now equal with a common denominator, I can just add the numerators together to get 31/36. Looking at that with another problem, the smallest number that I can fit both a 3 and an 8 into is 24. So I need to multiply the 3 by 8, and I'm going to do that on the top as well so that this fraction stays equivalent. That gives me 16/24 there. Here I'm multiplying by 3 for 3/24. And this problem, before I wrote over it, was a subtraction problem. So when I take 16 and subtract 3, I'm going to get 13/24. We can also find common denominators when we have more than 2 fractions. Oftentimes they end up being bigger numbers, but the same system still works. So the smallest number that is a multiple of 6 and 9 and 27 is 54. So in order to get 6 to be a 54, I'm multiplying by 9. In order to get 9 to be 54, I'm multiplying by 6. And in order to get 27 to be 54, I'm multiplying by 2. So when I go through and make my equivalent fractions, I get 45/54 from the 9 times 5 and 9 times 6, 24/54 for the 4/9, and 4/54 for the 2/27. Now that my denominators match, all I have to do is add the numerators. 45 plus 24 gives me 69, plus 4 more. Looks like it's going to be 73/54.